Hello. Hello, Bigneshwaram. Can you confirm whether my voice is audible or not? Hello.
Yes, ma'am, audible.
Okay, thank you. So, hello all. Welcome to the second section of uh, quantum mechanics course. I'm Gitanjali. I will help you to solve some questions which will help you understand the concept better. So, is everyone here? Okay. So let's start our section. So before starting the section, I want to have a short quiz. So you all can see my screen, right?
Yes, ma'am.
Okay. So there is a short quiz. It's a simple question. Uh, eh, by looking at it, you can also solve it. So read the question and tell me what will be the answer. This is the short quiz. Given two kits, Psi1 and Psi2. Psi1 is given by 351 plus 452 and Psi2 is given by 851 plus 552. So given Phi1 and Phi2 are orthonormal states. So what is the value of A? What is the value of A for Psi1 to be orthonormal to Psi2? Just look at what are the condition are given and according to that, answer the question. It's a simple question. Given phi1 and phi2 are orthonormal kits. These are given. Phi1 and phi2 are orthonormal states. So what is the value of A for which psi1 to be orthonormal to psi2? Everyone just read the question and answer what is the value of A such that psi1 to be orthonormal, or you can take it as orthogonal also. Let's just take orthogonal to psi2. Anyone solve it? You can tell me the answer. Just raise your hand and I will unmute your mic. Anyone? Read the question. Given there are two kits, psi1 and psi2. One is given as the superposition of two orthonormal kits, phi1 and phi2, and other is given psi2 equal to a phi1 plus phi phi2. So it is asking what is the value of this A such that these two states are orthogonal. Anyone know the answer? Okay, I think nobody knows. Okay, so let me solve it. Okay, so what is given? Psi1 and psi2 are orthonormal states. By orthonormal, what do you mean? Orthonormal means this condition. Condition for orthonormality. Everyone can see my screen, right? Akanksha, can you please confirm whether my screen is visible to everyone? No? Okay. Akanksha, you want to ask question? Akanksha, tell.
I was saying your screen is visible.
Okay. Okay, do you know the answer? Answer to this question?
No, ma'am.
Okay, let me solve. So condition for orthonormality is given by this form, like phi. If two states are given, phi I or phi j, then phi I, phi j inner product will be this one if I equal to j, and it is 0 if I not equal to j. Okay, this is the condition for orthonormality. So now given phi1 and phi2 are orthonormal states. So this means phi1 equal to 1 and phi2 will be equal to 1, but phi1 or phi1 will be 0. So So next the condition for orthogonal. So orthogonal means if it is saying that psi1 to be orthogonal to psi2. So this means psi1, psi2 must be equal to 0. If you take the inner product of these two states, then the inner product will be 0. So psi1 is given 3, 5, 1 plus 4, 5, 2. That is psi1, 3, 5, 1 plus 4, 5, 2. And so, and psi2 is a phi 1 plus 5 pi 2. So if you want to, here it is given the when you take the bra of psi 1 and take the inner product with the kate of psi 2, then it will be equal to 0. Now to find out the kate of this vector, you can just take the complex conjugate. So psi 1 is the complex conjugation of this kate vector. Now you are saying that all these are real. Means the constant are real. So it will be 3. And under complex conjugation, the phi 1 will become bra phi 1 plus 4 phi 2. It's like when you take the complex conjugation of this, it will become the bra vector of your, or if you are taking the complex conjugation of this, then it will become. So now just put it in the condition psi 1 plus psi 2 equal to 0. So this means a phi 1 plus 4 phi 2 and a phi 1 plus 5 phi 2. This must be equal to 0. So now if you multiply it individually, then only this term will remain. Phi 1 will give non-zero quantity. But when you take the inner product of phi 1 with the phi 2 here, there is a 3 here and there is a 5 here. So if you take the inner product, then it is 0 because these are orthonormal kits. So only non-zero quantity will be phi 1 with phi 1 and phi 2 with phi 2. So now you will get, so if you take 3, sorry, there will be a here, 3a phi 1 plus 20 phi 2 equal to 0. So now these are orthonormal kits. So it is 1, inner product of phi 1 with phi 1 equal to 1 and inner product of phi 2 with phi 2 equal to 1. So this will give 3a plus 20 equal to 0. That means 3a equal to minus 20 or a equal to minus 20 by 3. So this is the answer. So everyone understand this problem? Let's take another quiz so that you can understand it better. So let's say given same psi 1 equal to some like 4 phi 1 plus, or other state is given, which is let's say a phi 2 sorry, let's say B551 plus 25. Now the same question, like these states are orthonormal state. So tell me the value of B such that psi1 and psi2 are orthogonal. You have seen the previous question, how I solved it. So tell me the answer of this question. Just attempt it once. These are orthonormal. These phi1 and phi2 are orthonormal states. Given phi1, phi2 are orthonormal gates. Anyone wants to tell me the answer or the approach you can take to solve this question? You have to find out the value of B. And given phi1 and phi2 are orthonormal. Anyone? Yeah, Akansha. Let me. Okay. I have allowed your mic. Tell me.
B is equals to 5.
B equal to 5. Okay. Then Vigneshwaram, you want to answer the question?
B equals 0.
Okay. Okay. So the right answer is B equal to 0, is said by Vigneshwaram. Yash, you have some question or you want to answer the question?
Yes, ma'am, 0.
Okay. So the answer is 0. So here you are saying that B is associated with phi 1, right? So only and given psi 1, psi 2 must be equal to 0 for orthogonality condition. So this means 4, phi 1. If you take the bra phi 1 and this is B phi 1 with 20 phi 2. This must be equal to 0. But the psi 1 inner product with psi 1 will only give 1. But the inner product of psi 1 with psi 2 will be 0. So for this it is 4 phi 1. There is a B here also. It is 4B phi 1 phi 1 plus this is 80 phi 1 phi 2. So this term is only non-zero quantity, which is 1 here. This is 0 because here orthonormal means phi 1 phi j equal to 1 whenever these two indices are same, and if they are different then it will give 0. So this term will give 0 and this term will be 1. So for B equal to 0, that means B equal to 0. Yash, you have raised your hand. You want to say something?
No, ma'am, by mistake.
Okay. So now I think everyone is here and let's start our section. These are the short quiz. Let's start our first question. So everyone first read the question. Take your time to read the question. So given, consider a particle of mass m confined in a one-dimensional infinite potential well. And the potential will have this potential have this kind of configuration. So now what is this asking? Assuming the stationary state solution phi nx equal to root over of 2 by L sine n pi x by L. The expectation value of position and momentum operator turns out to be. So it is asking about the expectation value of position and momentum operator when the particle is confined to a one-dimensional potential well. So let's solve it. So expectation of position. So let's see what are the condition given. So given that stationary state solution, that is phi nx equal to root over of 2 by L sine n pi x by L. This is given stationary state solution. Now it is asking about the expectation value of x. So expectation value, how can you calculate it? This is equivalent to calculating the expectation value in this states. So you can write it as this phi nx x operator phi n, or in integral, this is the bracket notation. Now if you want to write it in the integral form, you can write it as phi n star x square phi n x dx. Okay. So given phi nx equal to this is the expression for phi nx. So you have to just put it in the integral so that you can calculate. So phi nx is given. How can you calculate the expression for phi n star x? So phi n star x is the complex conjugation of phi nx. So now you are saying that in this expression, everything is real. Sine function is a real function and 2 by L are constant. So if you take the complex conjugation of this function, it will turn out to be the same as the phi nx. X by L. So now if you put it here, so it will turn root over 2 by L sine n pi x by L skip 2 by L sine n pi x by L dx. So the limit is from 0 to L. Because the particle, you are seeing L is here. So the particle is confined to a box of length L. Now if you solve it, then will be sine square n pi x by L x dx. The x operator, when it acts on any function of x, then it will give x phi n of x. Now what you have to do, so you have to just express the sine square in terms of cos function. You know 2 sine square theta equal to 1 minus cos 2 theta. So this will be 1 minus cos 2n pi x by n dx. So I think everyone can solve it. This is from this equation. This is nothing but x dx minus x cos 2n pi x by n dx. So this is 1 by L. The first one will give x square by 2 from 0 to n. And for the second term, you have to take the integration by parts rule. So here you are seeing there are two functions. One is x, other one is cos. It's a cos function. So the first term will give what? L square by 2. But to calculate the second term, you have to solve it through integration by parts. Okay. Now, so anyone know about integration by parts rule? So the expression for integration by parts rule is given by this form. If two functions are given, one is f of x, other one is, let's say, g dash x. This is a function and you want to calculate its integration. Then it will be given as f of x, g of x minus integration of g of x, f prime of x dx. Okay. This is the integration by parts rule formula. So now you want to calculate the integration for these two functions. X cos 2n pi x by L dx. So now what you can do is express it. You can take it as take x as a f of x. So that here you are saying there is f dex x. So that if you take the f dex of x, it will give 1 in the second term. Don't take cos as a f of x, because if you take cos as f of x, then the derivative of f of x will be sine. Sorry, the derivative of cos will be sine. So this integration will continue for infinity times. So if you want to terminate the equation, you can take x as a f of x and cos as a z dash x. Okay, so that this term will give 1 in this form, in this equation. So now, so f of x is, if you put this in this form, then you can f of x, then z of x. So what is z of x? So z dash x is given, you are taking z dash x equal to 2n pi x by L. So if you want to calculate the z dash x, means derivative of z with respect to x, which is nothing but this. So g of x will be L by 2n pi sine 2n pi x by L. This is the g of x for your equation. Now if you want to calculate, then it will give f of x is x here, and this is L by 2n pi sine n pi x by L from limit 0 to L, and the other one is minus g of x abducens. So L by 2n pi sine 2n pi x by L dx. Now you are seeing that here two limits are given, 0 and L. Now if you solve this first one, what is the value you are getting? Then you will see that for the first limit 0, this term will give 0. And for the second limit L, if you put L in x here, then you will see there is a term sine 2n pi. Sine 2n pi is 0. So this means the first term is 0. Now for the second term, L by 2n pi sine 2n pi x by L dx. So this will give L by 2n pi square so and sine will give minus cos. From limit 0 to L. Now again, if you put the first limit, the upper limit, then what you will get? You will get a term cos 2n pi here. Then for the 0, it is cos 0. So this is also nothing but 0. So this means the whole integration, this part will give 0. So that means your expectation value of this term is giving 0. Only this term will remain. So expectation value of x will be 1 by L square by 2. So this is L by 2. Okay. This is the final solution. Now it is also asking about the expectation value of the momentum operator. So position operator you can we have now calculated, which comes out to be L by 2. Now we have to calculate the expectation value of momentum operator. So momentum operator, anyone know what is the expression for momentum operator? So this is nothing but IH cut. Akanksha, you want to tell something?
X plus by I dou by dou x.
Okay. It is dou by dou x. So now you want to calculate the expectation value of P. So same as the expectation value of X. So it will be, it is the phi n. This is phi nx. P operator phi n. Now you can write it as a integral form. P phi n x. So just write the expression for the momentum operator. This will come out as a 2L sine n pi by L, n pi x by L. And other one is dou by dou x of this momentum operator will act on the second state. The next phi, it will act on the phi next 2 by L. So it will be sine n pi x by L dx. So now just write what is the derivative you are getting. It will be 2 by L. Then there is a sine term here. And the derivative will give, the derivative will act on sine function. And it will give a cos function. Cos n pi by L dx. And there will be a constant factor also, which is n pi by L. So now if you solve it, n pi by L, there is a L here also. So this 2 sin A sin B. What is the final expression for 2 sin A sin B? Sorry, 2 sin A cos A. Here, these expressions are same. So the final expression is sin 2A. Okay. Like sin A plus B, you know the this trigonometric equation, right? The sin A plus B equal to sin A cos B plus cos A sin B. So if A equal to B, then it will become sin A cos A plus cos A sin A. So the final term is 2 sin A cos A. Okay, so this is nothing but sin 2A, 2 n pi x by L dx. Now I think everyone can solve it. This is easy to solve. One by L, and there will be a constant factor will come out. So this will give minus cos 2n pi x by L from 0 to L. Okay. Now if you put the upper and lower limit, this will give cos 2n pi for L, and for 0 it will be simple cos 0. So this is nothing but a 0. So that means this whole term is 0. So the expectation value of momentum operator will be 0. So the first question is solved. Anyone has any question regarding this first question? Otherwise, I will move to the next one. Okay, Yash.
Hello, ma'am.
Tell.
Yes, ma'am. I don't have question regarding this, but I have some another question. Can I ask?
Tell me.
Yes, ma'am. Ma'am, I want to ask that where can we get all these links of this recording that either we have to revise again?
So it will be shared with you. They will
Okay.
share the whole recording as well as the question I am solving. They will share with you. It will be
Ma'am,
shared.
where we will get?
They will share the link.
Okay, okay.
So let's move to the next question. Next question is, consider a particle in the infinite square well of finite width A with its initial wave function such that the first two stationary gates as a relative phase factor, which is given by this. So this is asking about what is the expression for this one. So what is given? Given psi of x0 equal to a psi 1x plus e to power I5 psi 2x. Now it is asking about what is the value of psi of a by 2 t square. What is this value? So let's solve it. So given this is given to you, and you have to find out what is the value of this function at a later time t. So, and it is also given that this phi 1x and phi 2x are stationary gates. These are stationary states. So now to find out the value of a wave function at a later time t, let's say t, then it is nothing but e to the minus h t by h cut acting on the initial wave function. Whatever initial wave function given to you, it will act on it and it will give the value of wave function at a later time t. So first, and you are saying that there is in the answers there is no a term here. Like there is a term here, right? So there is no a term here. So first, what you have to do, you have to normalize the wave function. So what is the normalization condition? Normalization condition is given by this form. So psi x0 square dx equal to 1. This is the normalized wave function. Normalization condition. So now if you, and this is nothing but, you can write it as a psi star x0 this is the capital psi star x0 psi of x0 dx equal to 1. So psi of x0 is given to you. Psi of x0 is psi 1x plus e to the I5 psi 2x. So if you want to take the complex conjugation, then will be a star and this will be psi 1 star x plus e to the I5 will become e to the minus I5 and this is nothing but psi 2 star. Okay, now you have to put this two forms in this equation to find out the value of a. So this is nothing but this will give a square, this a and a star. This is psi 1 star x plus e to the minus I5 psi 2x and another term is psi 1x plus e to the I5 psi 2x, which is equal to 1. Now similar to the orthonormal condition, here the question tells that these psi 1 and psi 2 are stationary states. So this means they are orthonormal states of this particle. So that means the psi1 star is psi1 will be a non-zero quantity, but psi1 star with psi2 will be a zero quantity. Okay, so you just have to take the terms which are non-zero. So this is a square and this is psi1x plus psi2x dx equal to 1. And this is a square so if you assume that particle is confined in the 1D potential well is given. So let's just take, let's say it is 0 to L. So in this potential well, this term will give 1 and this term will give 1. This is 2 equal to 1. So A is nothing but 1 by root 2. So this is the value for the normalization constant. So remember this equation. This is the normalization condition for normalization. And now you know the value of A. Just put it in this equation. This will be psi of x0 equal to 1 by root 2. And what is this is psi1 x plus e to power I5 psi2 x. So now you have to find out the value of this wave function at a later time t. So for that we have to apply the time evolution operator which is given by this form and apply this time evolution operator on the initial state. This is the initial state and this will be the final state after some time. So this is nothing but minus IH T by H cut 1 by root 2 will be here psi1x plus e to the I5 psi2x. Now when this time evolution operator will act on these stationary states, then it will take out the eigenvalue of that state. Like for psi1, the eigenvalue is E1, right? For psi2, let's say the eigenvalue is E2. Then when the time evolution operator minus IH T by H cut, when it acts on the wave function, then it will simply give minus E1 T by H cut psi1. And when it acts on the second state, psi2, it will give minus E2 T by H cut psi2. So it just take out the eigenvalue of that wave function. So now if you put this two equation in this form, so psi of xt equal to 1 by root 2 e to power minus e1 t by h cut psi1x plus e to power minus e2 t by h cut psi2x. Okay, I think I have missed this phase factor here. There is a phase factor here also. So there will be one extra term which will appear here. e to the I5 psi 2x. So everything is clear up to here. Now the question asked about this. What is the value of this? So for that we have to take the square of this final equation. So psi of x. Let's say we are calculating for some arbitrary x. So this is I1 star xt, which is the complex conjugation part of x, psi of xt and psi of xt. So now we just have to take the complex conjugation of this equation and multiply it with the initial form. So what will be? So I think everyone can calculate for now what is the complex conjugation of this equation. So this complex conjugation will give nothing but 1 by root t is a constant. So it will make e to the minus I1 t by h squared. Minus it will make this minus I to plus I. Okay. This is psi star and this is e to the I e to t by h squared. E to the minus I5 psi 2x. Okay. Now this is psi star. So a whole square equal to nothing but psi star xt and psi of xt. So just put the values. This 1 by root 2 will give 1 by 2 and this will give this term will give psi of x square, right? And this term it will give psi 2x square. You are just multiplying this equation with this equation. Okay. So this is now there will be one term which is this is the first term. Now if you multiply this term this with this one, then you will get one term which is e to the power I e2 minus e1 t by h squared e to the power minus I5 okay. So this will be this term with this term. If you multiply it, then it is e1 minus e2 t by h squared e to the power minus plus I5 and psi 1 star x and psi 2. And there will be another term which is multiplying this equation with this. So this will give e to the power I e2 minus e1 t by h squared e to the power minus I5 and psi 2x. Sorry, this is star, right? Psi 2 star and psi 1x. This is the final count. So now let's solve it one by one. This is one term. So psi 1x square. This is nothing but this is 2 by a sine square pi x by l. Not a. This is a. And psi 2x square, it will give 2 by a square 2 pi x by a, and the third term, this term and this term. If you see it, this term has one common factor. Like you know that in 1D psi 1x is given by root over root 2 by a sine pi x by a. So if you take the complex conjugate psi 1 star x, then this is equal to psi 1x, right? So similarly for psi 2x must be equal to the complex conjugation of this. So now this means these two terms are same. So we can factor it out. So the third plus fourth term, this is the first term, this is second. Third plus fourth term will give psi 1x, psi 2x, and e to power series e to power I5 I2 E1 minus E2 T by H cot plus e to power minus I5 e to power I E2 minus E1 T by H cot. Okay. Now what we have to do? Now the question is asking about what is the value of this at a particular position x equal to a by 2. So we have to find out the psi of a by 2 t square, right? So now if you put this means you have to find out the solution for x equal to a by 2. Now put the x equal to a by 2 in first term, second term, and third and fourth term. So first term will give this 2 by a sine square. This is nothing but pi by 2. So this will give 2 by a, right? So the second term will also give, second term is 2 by a sine square 2 pi x by a. So this will give a by 2. Then this will give 0 because it will become sine pi. Now the third and fourth term. So this is nothing but psi 1x, psi 2x, e to power. First calculate what is the value you are getting the psi 1, psi 2, then you can multiply it with the exponential term. So psi 1 is 2 by a sine pi x by a, and psi 2 is 2 to the power 2 by a sine 2 pi x by a. So now you are saying that if you put x equal to a by 2 in this equation, then this term will give 0 because it will become sine pi, right? So this means this whole term will give 0. Okay. So what you left with, only the non-zero is this term. So this is the only non-zero quantity you are getting. So this means the a by 2 t whole square is this will be so to put this you will get 1 by 2 here. There is a 2 by a here. So you are seeing that there is a 1 by there is a 1 by 2 here. So this means 1 by 2 into 2 by a. This is 1 by. So the final equation is this, final solution is this. So what you have to keep in mind is what is the time evolution operator, how you are getting the time evolution of a given state. So you have to just put the time evolution operator on the initial gate, and when you act on the time evolution operator on its state psi1, then it will factor out the energy eigenvalue of the state. Okay. So this question, this problem is also clear. So let's move to the third one. So everyone just read the question. So the question is, particle in the infinite square well of width A has its initial wave function as an even mixture of the ground state psi1 and the first excited state psi2, which is given in this form. Now it is asking about the expectation value of the position at time t. What is the expectation value of the position? Now just look at the answer first. What is the answer given? So here we are saying that there is no capital A term here. That means we have to first normalize the wave function. Okay, so your first steps will be normalize it. So the normalization condition is, now everyone knows what is the normalization condition. It is nothing but dx equal to 1. So it can be written as x0 psi1 x0 dx equal to 1. Now psi of x0 is given to you, which is a psi1x plus psi2x. Okay, so now psi star x0 is nothing but a star psi1 star x plus psi2 star x. So just put this equation in the above form. So this will give a star will give a square, and there will be psi1 star x psi2 star x plus psi1x plus psi2x dx equal to 1. So you have to just keep in mind the orthonormal condition. That is, I have told you before starting the section, I have told you that this is the orthonormal condition. That is, whenever two states are same, they will give 1. When two states are different, they will give 0. Within that boundary, means within the region where the wave function where the particle is confined. Okay, this is valid when the x is defined within the region where the particle is confined. Let's say it is confined between 0 to L. So within 0 to L, this equation will be valid. Okay. So now we have to, so you can just write it as a psi square, psi1 square plus psi2 square. The other terms, the other cross term like psi1, psi2 and psi2, psi1 star psi2 and psi2 star psi1, it will give 0. So I have not written it. So here, this is nothing but this are orthonormal, this will give 2, 1. So this means, sorry, let me write it down properly. So a square, you can take it out from the integration. So this whole term will give psi1 square plus psi2 square dx equal to 1. So let's say the particle is confined within 0 to L. So you can take the integration as 0 to L. So this is this, and this will be 0 to L psi2 square dx equal to 1. So this term will be 0 and 1, and this term will be 1. So this means a squared 2 equal to 1 or a equal to 1 by root 2. This equation is this problem is similar to the problem solved before, like the second one. So I will speed up them. So psi of x0 will be 1 by root 2 psi1 plus psi1x plus, this is the capital psi, okay, psi2x. Now to find out the time evolution of this, so we have to take psi of xt equal to e to power minus IH a by h cut psi of x0. So it is nothing but 1 by root 2. So the 1 by root 2 e to power minus IH t by h cut psi1x plus e to power minus I t by h cut psi2x. So I have told you that when the Hamiltonian operator acts on this, when this time evolution operator acts on this state, it will give e to power minus e1 t by h cut psi1, and this will give e to power minus e2 t by h cut psi2. Okay. So now the final form will be 1 by root 2 e to power minus e1 t by h cut psi1x plus e to power minus e2 t by h cut psi2x. So take the complex conjugate. The complex conjugate will be 1 by root 2 e to power I1 t by h cut psi1 plus e to power, this minus I will come plus I. So this will be e2 t by h cut psi2. Okay. So now what is it asking? So this is asking about the expectation value of position at time t. We have to find out what is the value of x here. Okay. So x is nothing but we will get psi, this is psi of xt, x operator, x acting on psi of xt. So you can write it as a psi 1 star xt, x psi of xt dx. Now let's just take this whole term. So okay, let's calculate psi 1 star xt with psi of xt. Because x there is no operator here now. X acting on this will simply give x. So first calculate what is the expression for here for this form. So this is 1 by 2. You have to take this 2. So this will nothing. This will give psi 1 square. Multiply this with this. Then the other term will give psi 2x square. Then there will be a cross term here. Like when you multiply this with this, similar to the previous one, there will be cross term here. It by u1 minus u2 dy h cut. This all are star, but as they are real function, the psi 1 x star will be equal to psi 1. This will give psi 1x psi 2. Plus there will be a term which will be equal to e to power I e2 t by e1 minus e2 t by h cut psi 1x with psi 2x. Okay. Now you are saying that let's see this two form. There is a common factor here, psi 1, psi 2, psi 1, psi 2. So if you see these two terms, psi 1x, psi 2x, there is a term e to power I e1 minus e2 t by h cut plus e to power I e2 minus e1 t by h cut. So this is like e to power minus I theta plus e to power I theta. Theta means e2 minus e1 by h cut t. So what is this term? So this is nothing but 2 cos theta. Okay. So this is one of the trigonometric equation. This is cos. This will give e2 minus e1 t by h cut. Okay. Now you can write it down the final form. Psi square will be equal to 1 by 2 psi 1 square plus psi 2 square. Keep in mind these two are not same. This state and this state are not same. This is other side. And the third term will be 2 times psi 1 psi 2 cos e2 minus e1 t by h cut. Now you have to just put this form in the integral. In this. So now x will be 1/2. This will give x psi 1 square plus x psi 2 square plus 2 psi 1 psi 2x cos a2 minus c1 h cut t into dx. So psi 1 psi 2, psi 1 psi 2 are nothing but the normalized wave function. This is for the first state. This is pi x by L. And psi 2 is root over 2 by A will be sine 2 pi x by A. Now if you have to, you have to use the integration by parts rule that I have told you earlier. This is x, there will be 2 by A. This will become sine square pi x by L. Other term is x into 2 by A sine square 2 pi x by L. And the third term will be 2x sine pi x by L sine 2 pi x by L. And there is a cos term here. Okay, cos term here and dx. So now just use the integration by parts rule. So first what we have to do, we have to write the sine square term as a cos. In terms of cos, it will be 1 minus cos 2 theta 2 pi x by L. Similarly, for this term, you have to write it down as a 1 minus cos term. And this term, this is nothing but 2 sin S cos sin B, which you can write it as a cos A minus B minus cos A plus. So use this in this equation. So after using it, you can find that the final form will be 1 minus 32 A final form will be like this. Okay, here omega is nothing but wait 1 minute. So here omega is h cut pi square by 2n square. So just use the integration by parts rule. You can get it. Okay. Now let's move to the next question. Everyone read it once. The next question. So it is given, suppose psi of xt equal to root over of 2 by A. This is given to you. Is the wave function for a particle in the region 0 to x and x less than 0, x greater than 0 and x less than a. Now it is asking about the probability of finding such a particle in the interval a by 4, x and a by 2. So it is asking about the probability of finding the particle. So let's see what is given. Psi of xt is given to us, which is root over of 2 by a sin pi x by a e to power minus 2y omega t. This is given to us. So probability of finding the particle. So probability for finding the particle between a by 4 and a by 2. So the probability is given by is nothing but psi square dx from, and the limit will be in that region where they are asking the probability. So it will run from a by 4 to a by 2. Now psi of xt is given. So you have to find out what is the value of psi star xt. So psi star xt will be root over of 2 by a sin pi x by a, and this minus item minus 2y term will become plus 2. So it will be 2y omega t. Now use this equation and put it in the interpreter. So this is a by 4 to a by 2. There will be a constant factor of 2 by a and sine square pi x by a dx. This term, this e to power 2y omega t with e to power minus 2y omega t will give 1. Okay, so that is why I have not written it. You now solve it. So you can write it as a 2 sine square pi x by a dx 1 by a, and 2 sine square you can write as cos 1 minus cos 2 pi x by a dx. This is nothing but x from a by 4 to a by 2 minus this cos term integration will give sine a by 2 pi, constant factor will come out. This is nothing but sine 2 pi x by a. From a by 4 to a by 2. So 1 by a, this will give a by 4 minus. Now this is a by 2 pi. Now if you see the upper limit, then it is sine pi minus the lower limit is sine pi by 2. So this term is 0. So the final is a by 4 minus plus a by 2 pi. So this is 1 by 4, 1 by 2 pi, which is nothing but 2 plus 5 by 4 pi. This is the final. Solution. Okay. So what we have to note down here is how to calculate the probability. The probability is given by this form. So if you want to find out the probability, then you have to just take the square of this wave function and find out what is the value of integration within that region. So the answer comes out to be this one. So remember it, this probability question. Now let's move to the next one. Up to now, up to fourth question, do anyone has any doubt? You can ask now if you have any doubt. So okay, so let's move to the next question. So the question is, a particle of mass m is confined to a one-dimensional region 0 to x as shown in this figure. Okay, so the particle is confined in this region and at t equal to 0, its normalized wave function is this. Psi of x t0 is given by this equation. This is given to you at t equal to 0. Now it is asking about what is the Sanjeev, this whole questions and the document, it will be given to you in document format also. Like in PDF form, this will be shared with you. The lecture as well as the question with answers, it will be given to you. So, but for now, understand what is the concept. Means uh, at least see whether you are getting the concept or not. It will be shared, Ankit. It will be shared with you. So let's move to the next one. So what is given? So given to you psi of x equal to 0 equal to root over of 8 by 5a 1 plus cos pi x by a and sin pi x by a. The videos are already the four videos and the file means the document file. It will be shared means it will be uploaded. The first video is uploaded. It will be shown shared with you. But just for now, keep patience. They will share all this material with you. Don't worry. So now let's look at what is it asking? What is the wave function at a later time t equal to 0? So for that, what is the wave function at a later time? You have to apply the time evolution operator. So the time evolution. So I have told you earlier that the time evolution operator is expressed in terms in this form psi of x 0. So now if this initial wave function, if this initial wave function is given uh, uh, some superposition of two states, so then let's say phi 1 and phi 2, then I told that it will factor out the eigenvalue. For phi 1 it is E1 t by h cut, phi 1 it will give, and if it is phi 2 it will give E2 t by h cut phi 2 when the time evolution operator acts on it. So now you have to then express this equation in terms of normalized wave function. It is not expressed in terms of normalized wave function, so you have to express it first. So for the 1D potential well, what is the normalized wave function expression? It is given by root over of 2 by a sine n pi by a x. Okay, this is the expression for the 1D potential well. So 1D potential well, I think everyone knows how you get this form. I will briefly told you how you are getting this form. So let's say the potential is like this. So inside this region, the potential is 0, right? So this means if you write the Schrodinger equation, so this is h square by 2m dou square psi by dou x square. Potential is 0, so this will be p psi. Now dou square psi by dou x square minus 2m e by h cut square psi. Now you have to take it as a constant. It is a constant k square psi. So if you solve this double differential equation, double derivative differential equation, then you found that the allowed solution are a sine kappa s, where kappa is nothing but n pi by a. Okay. Now let's look at what is given to us. So it is given 8 by 5a 1 plus cos pi x by a and sin pi x by a. So you have to express it in terms of the normalized equation, normalized form, wave function. So you can write it as a pi x by a sine, and the other term is root over of 8 by 5a cos pi x by a and sin pi x by a. So now if you look at this form, here n is 1, right? If you compare this form with this form, then here n is 1. So this means this corresponds to psi 1 state. So you have to express it in terms of, so take out the root over 2 by a, there will be root over 4 by 5 here, and sin pi x by a for the first term, and for the second term you are seeing there is 2 terms, cos and sin terms. So we have to use the trigonometric form like 2 cos a sin a equal to sin 2a. Okay, so it will be root over of, there will be 2 by a here. First write it. So it will be root of 5 by a. Just take out the 4 here and you will get 2 cos pi x by a sin pi x by a. And this is nothing but sin 2 pi x by a. So the final form will be root over of 4 by 5. This is, let's say, phi 1, here phi 1x. This is phi 1x, and this is 1 by root over of 5, root over of 2 by 8, sine 2 pi x by 8. Now similarly, you compare this form with the normalized form here. Here you can see n is 2 here. So this means this state is phi 2. So the final form will be root over of phi 1x plus 1 by root over of phi 2x. Okay, now we have to apply the time evolution operator to this state. So psi of xt is nothing but e to the minus st by h cut root over of 4 by 5 pi 1x plus 1 by root over of 5 2 x. Okay, now just take this time evolution operator inside, then you will see that when this will act on this phi 1 state, then it will factor out the energy of that state, take out the energy of state, and when this term acts on this term, it will be 1 by root over of 5 e to the power minus I into d by h cut by 2x. So this is the final form of the time evolution. What is the wave function at time t equal to t0? For t equal to t0, you can simply replace t with t0. Okay. So the first one is done. Now it is asking what is the average energy of the system at time t equal to 0 and at time t equal to t naught. So average energy, it's like if it is asking about average energy or expectation value, so they are same. So is asking about the average energy, then you can write it as this. Okay. Expectation value, you can write it as a for t equal to t. Let's say the first one t equal to 0. So this will be the initial state x0 h psi of x0. Now this you can write it as a psi of let's see what was the value of the wave function of initial state, that is psi of x0 is nothing but psi of x0 is this one. This is the initial state. So this is 2 by root over of 5 pi 1x plus 1 by root over of 5 pi 2x. Right? So now you have to take the for this, put this way expression in the expectation value. This is let's solve it in the bracket notation. So now you can write it you can write this as a sum kth vector 2 by root over 5 1 is 1 by root over 5 2. Now if you take the bra vector of this kth, then it will become root over 2 by 5 1 and 1 by root over 5 2. So now we have everything. So we can solve now this expectation value phi of x0. So this is 2 by root over 5 1 plus 1 by root over 5 2. This h acting on the kth vector. Right. This is 1 plus 1 by root of 5 2. Now when the Hamiltonian operator, when it acts on a state, then like the time evolution operator, it will also factor out the energy. So E1, it will give you V1 phi 1. And when H acts on phi 2, it will give E2 phi 2. So put this in this form. So root over 2 by root 2 phi 1 is 1 by root over 5 phi 2. Then this term, when this Hamiltonian operator acts on this, it will give 1 by root over 5 E1 phi 1. And when it will act on this, it will give 1 by root 2 root 5 phi 2. So you have two terms here. So now you know that phi 1 and phi 2 are the normalized states of this particle, which is confined inside this potential well, infinite potential well. And there will be no break. So these are the normalized wave function. So this means when you take the inner product of phi 1 with phi 1, it will give 1. And when you take phi 1 with phi 2 or phi 2 with phi 1, it will give 0 within this reason. So now H will be, now only non-zero term will be this multiplied by this and this multiplied by this. So this is nothing but 4 by 5 E1 phi 1 phi 1 plus 1 by 5 E2 phi 2 phi 2. So the final, this all are 1. So 4 by 5 E1 plus 1 by 5 E2. Okay, now use this expression for 1D potential well. E1 is written as, what is the expression for En? En is written as h square by 2n n pi by L square. So put n equal to 1 and calculate it, and n equal to 2, calculate what is the value you are getting. Now put this value in this final form, E1 plus 1 by 5 E2. So the final one you will get is 5 h square divided by 5 m square. This is the final. So this first part is done. Second part. So for the, this is for t equal to t0. What is the expectation value of energy you are getting? Now for t equal to t naught, what you have to do is you have to use this wave function. Okay. So this wave function, so let's solve it. Yes. So let's take it to this place. So this is the equation for psi of xt. So this is the expression for psi of xt t equal to t0. So if you want to find out the Hamiltonian, follow the same procedure, but instead of psi of x0, you have to put psi of xt here. Okay. So you can write it as xt0 in terms of gate vector, which is root over 4 by 5 e to power minus I e1 t by h cut I1 plus 1 by root over 5 e to power minus I e2 t by h cut phi 2. So the gate of this bra of this wave function will be root over 4 by 5. It is nothing but the complex conjugation of the gate vector. Okay, so the minus I term will become plus I. This will be gate, sorry, bra. And this is 1 by root over 5 e to power I e2 t by h cut phi 2. So now act calculate this form. This is nothing but psi of x t0 and h acting on psi of x acting on this state. So let's write it down. 5 e to power. Let's write the whole term. So root over of 4 by 5 e to power minus I plus I e1 t0 by h cut phi 1 plus 1 by root over of 5 e to power e2 t by h cut phi 2. This one, and there is a Hamiltonian operator. This will be root of 5 e to power minus e1 t0 by h cut phi 1 plus 1 by root over 5 e to power phi t0 by h cut. This will be t0 here. Now, as I said, the H operator, when it acts on this state, it will give E1 psi 1, phi 1, and when it acts on this state, it will give E2 psi 2. So just write it down. What is the expression you are getting? E1 T0 by H cut phi 1 plus 1 by root of phi E2 T0 by H cut phi 2. This term multiplied by with root over 4 by 5 E2 T0 by H cut phi 1. And there will be E term here, E1 term, because Hamiltonian operator taps on this one and gives A. And the other term is 1 by root over 5 minus I into T0 by h squared E2 right. Now you see that this term multiplied by this, the inner product of this term will be non-zero and the inner product of these two terms is non-zero and inner product of these two terms is non-zero. So the final and this term inner product will be 0, or if I take the inner product of this with this, it will be 0. So the final will be phi 1 with phi 1, phi 2 with phi 2. So the constant factor will be get multiplied here. So this is 4 by 5 E1 plus 1 by 5 E2. This is the same form. This is the same solution which we get, like it is similar to this. For T0, T equal to T0, we get this. And for T equal to T0 also, we are getting this. Now everything is okay for now. You are understanding what I am telling? Does anyone have any doubt? Okay, Ram Babu, it will be shared. The recorded videos will be shared with you. It will be shared. The video link, all the solution and all this question set will be shared. So let's move to the final last third question. Third question. So now it is asking what is the probability that the particle is found in the left half of the region x line between 0 to a by 2 at t equal to t0. So probability, I have told you how to calculate probability. Probability is, no, there is no WhatsApp group for this subject. So C is to find out the probability that particle will be found between the left half of this region. Like the particle is confined within 0 to a. Now it is asking about what is the probability that the particle will be here, the left half. So this is nothing but will be 0 to a by 2. Let me see the question again. So it is asking about at t equal to t0. So at t equal to t0, we have to take this wave function. Okay. Don't take the initial wave function. Can we make one? No, we can't make, but if you have any doubt, you can ask now. Psi of x. Ankit, do you have any doubt? Will be this. Okay. So this is nothing but psi star x t0 and psi of x t0 dx. So I think for now everyone can solve it. I have showed you the detailed procedure also in the previous question. So this psi of x0 is nothing but 2 by 2 to the power of 5 e to the power minus 5 T0 by h cut psi 1x. There is another term 1 by root over of 5. Then e to the minus 2 minus a2 T0 by h cut psi 2 x. So now, okay, thank you. Thank you, Ankit. So now what you have to do, sorry, this is the psi 1 term. You have to take the complex conjugation of this so that you can calculate this. So psi 1, the complex conjugation will be, the constant will remain as it is, only the, whenever there is a minus psi term, it will become plus psi. Psi 1x plus 1 by root of 5 e to power I v2 t0 by h cut psi 2x. So now use this equation and solve the probability. Is 0 to a by 2. So the one thing you have to remember is that don't take don't take this psi 1 with psi 2 equal to 0 here. Okay, this condition is not valid now because you are calculating the integration in this region, the some part of this region. That is why you can't take psi 1 with psi 2 equal to 0 or psi 2 with psi 1 equal to 0. This you can't take now. Even if the condition is like find the probability between 0 to a, like though in the whole region, then in that case you can take this condition like psi 1 with psi 2 equal to 0, psi 2 with psi 1 0. But for now it is non-zero. So now use this two equation and calculate the probability. Now it is almost time. So I think I can solve it in the next lecture. So, but for now, is anyone have any doubt regarding any question? If you have any doubt, like any conceptual doubt, you can ask. So for okay, for this case, what we have to do is first you have to, instead of writing, you have to take whole term like psi 1 with psi 1 and psi 2 with psi 2 and another cross term also psi 1 with psi 2, psi 2 with psi 1. And using the whole term, you find out the integration, what are you getting. Like I have solved one of the question for probability, I think in one of the question, this one. So similar to this, calculate the probability of this one, this question. Okay, so put psi 1 x equal to root over of 2 by a sin pi x by a and psi 2 equal to root over of 2 by a sin 2 pi x by a. So use this formula and calculate the integration. I think you can solve it. The final solution you will get is, I think, let me see the solution. This is the fifth question. So the final solution, I have written down the whole procedure here also. So probability of finding it in the left half. So the final one you will get is, where is it? This one. This one. I think this one. This is the final probability that you will get. You have to multiply, means we have to calculate the, look, there are psi1 term here, there are psi2 terms here, and there are cross term here also. So you have to just take the integration of the whole terms. Okay. So anyone has any doubt now? Which book would you recommend for quantum mechanics? So just follow the one that is suggested by professor, like Griffith. You can start from Griffith and read the book and solve the problems that is given there. Then you can understand it. So anyone has any doubt in these questions? So you can ask in the discussion forum if you have any doubt regarding these problems. Like I have solved these problems, right? When this videos and the seat will be said with you. If you have any doubt, then just write it down in the discussion forum of the class. Then I can clarify your doubt there. So anyone has any doubt? In any one of the question? So then I think I can end the section now. Is it a I will not upload it, but the NPTEL team, they will share these files and these video links with you. So the recorded video will be uploaded in YouTube. So you can, after when the link will be shared with you, then you can see that. So now nobody has any doubt, right? So I can end this section, right? So let's just end this section now. Thank you all for joining this section. I think whatever I have solved, you have understood it. So if you have any doubt regarding any question, just write it down in the discussion forum. Doubt regarding any this question I have solved, write it down in the discussion forum. Then I will clarify the doubt there. Okay, let's end for now. Thank you all. Bye.